Hello everyone. Through this video we are going to discuss some of the important questions of exercise 4.5 in the chapter of determinants. I'm starting with question number 9. Actually in this part we have to find out inverse of the matrices if it exists in the given exercises. So here is the matrix given in number 9. We already know that the formula for finding out inverse of any matrix, any square matrix, capital A, is this one: 1 by determinant of A into adjoint of A, provided that determinant of A is not equal to 0. So in the solution part, while starting with, first of all we have to evaluate the value of the determinant. So I would prefer to expand this determinant 2, 1, 3, then after 4, minus 1, 0. Actually determinant of this matrix, this given matrix I am taking minus 7, 2, 1, and we have to assume this given matrix to be capital A. So expanding along the first row, I shall get 2 into this determinant. I need to consider the first row and the first column I have to delete, and whatever elements are left behind I have to construct an order 2 determinant and then expand. So minus 1 will be the result here. Minus 1 will be the result. Then after followed by 2 into 0, it will be ultimately 0. Then minus 1, 4, product of these two, then minus plus 0 plus 3, I get here 4 to the 8, then minus 7. So let us check what answer we get here. It is minus 2, minus 4, then after plus 3. So result comes as minus 3, which is a non-zero quantity, not equal to 0. Then after, for finding out inverse of the matrix, the next important thing that we have to find out is adjoint of the matrix. So for finding out adjoint of the matrix, we first need to get what are the cofactors of this given matrix. So since we get here determinant of A is a non-zero quantity, non-zero number, therefore A inverse exists. We have to write like this. Now we shall come to the cofactors of matrix capital A equals to, let us write down the given matrix here once, 2, 1, 3, then 4, minus 1, 0, then after minus 7, then 2, 1. Let us find out the cofactors here. We denote the cofactors as this. For finding out cofactors, we have to use the sign conventions also. This is the sign convention: plus, minus, plus, minus, plus, minus, then again plus, minus, plus. So the first term, A11, capital A11, this stands for cofactor of the first of the element lying in the first row and the first column. That means for 2 we are finding out the cofactor. So the element, it is lying in the first row and the first column, therefore we have to exclude this row and column, and whatever elements are left behind, out of that we have to construct a determinant. So this is the determinant of order 2. Of course this will be positive. The positive sign convention we have to use here, and the result comes as, after expansion, it will come as minus 1, minus 0. It is ultimately minus 1. Similarly, let us find out the next one, A12. It will be this will be 4, means minus sign convention I have to use here. 4, 0, minus 7, 1 will be minus 4, minus 0 will be minus 4. Then A13, for this I have to consider this determinant: 4, minus 1, then minus 7, 2. the result will come as 8 minus 7, it is 1 ultimately. So these are the cofactors of the elements along the first row. So let us calculate the cofactors, values of the cofactors along the elements, along the second row. So 8 to 1, this sign convention I have to use here. Of course minus will come, then these elements will construct this determinant 2 1. So here I get minus 1 minus 6, result will be 5. So 8 to 1 I got as 5. Similarly 8 to 2 I got as 8 to 2 will be 2 3 minus 7 1, the result will come as 2 plus 21, it is 23. Then after this 8 to 3, this is negative of 2 1 minus 7 2, it is negative 4 plus 7, it is minus 11. So here in this case these are the results for cofactors of the second row. Here comes the third row. A 3 1 will be equal to the positive sign convention I have to use here, of course, because this is positive. So here it will be 1 3 minus 1 0, it will be, it is 0 plus 3, ultimately result comes as 3. Then after A 3 2, negative sign convention I have to use here. For A 3 2, elements will be 2 3 4 0, 2 3 4 0, and I can write here minus 0 minus 12, answer is 12. And then after A 3 3, the sign convention will be of course positive, and the elements will be 2 1 4 minus 1, it is 2 1 4 minus 1, the result will come like minus 2 minus 4 equals to minus 6. So these are the cofactors. So we can write down the adjoint in this way. Adjoint of capital A is equal to, first let us write down the cofactors. Along the first row the cofactors will be minus 1 minus 4 and 1, minus 1 minus 4 and 1, minus 1 minus 4 and 1. Along the second row it is 5 23 and minus 11, 5 23 and minus 11. Then after 3 12 minus 6, so it's transpose we have to find out. While finding out the transpose we get the results, as minus 1 5, then 3, then after minus 4 23 12, then after we get 1 minus 11 minus 6. So these are the results I got here for adjoint of A. Therefore inverse of the matrix A could be given by 1 by determinant of A into adjoint of A, and the values we get as 1 by minus 3, as the determinant value we already got as minus 3. So here I put the determinant value, the matrix value for adjoint of A. It is minus 1 5 3, then minus 4, then 23, then 12, then 1 minus 11 minus 6. So this is how we can get the result for adjoint of result for inverse of the given matrix. So this is the answer. Then coming to question number 10, the given matrix is Coming to question number 10. Given matrix is, let capital A equals to, the matrix given is 1, minus 1, 2, 1, minus 1, 2, then after 0, 2, minus 3, then after we get 3, minus 2, 4. Again, in this case we have to check whether determinant of A is non-zero or not. So expanding along the first row, I get 4 2 ja 8 here, then minus 6, followed by minus of minus 1. Then after this row and this column I have to delete. So after this, whatever elements are left, the determinant expansion I have to consider here 0, then plus, it is 9, plus I have to put here 2, then after 0, minus 6. I get here the result to be 2, then after plus 9, then minus 12. The answer will become minus 1, which is again a non-zero quantity. Therefore, A inverse exists. Next, there comes the cofactor matrix. Cofactors of these elements of the given matrix we have to get here. So I shall be writing here the cofactors of elements of matrix capital A equals to, let us write down the elements of the given matrix once again. 1, minus 1, 2, then 0, 2, minus 3, then I get here 3, minus 2, 4. So after getting these cofactors, let us find out. Here in this case it will be this, like the previous sum, only we have to do here. So it is 2, minus 3, minus 2, 4. The result comes as 8, minus 6 will be 2. Then A 1 2 comes as negative of 0, minus 3, then 3 4, determinant of these 4 elements. Then after the result will come as negative 9. Then after A 1 3, this will be 0, 2, 3, minus 2, and our answer will be 0, minus 6. It is minus 6 here. Then after similarly A 2 1, negative sign convention I have to use here. So in this case it will be minus 1, 2, then minus 2, 4. That is equal to minus 4, then plus 4. Result will become 0 here. Then A 2 2. In this case, let us find out the cofactor. The sign convention will be positive, of course. So 1, 2, 3, 4 I get here. Then 4 minus 6, the result will come as minus 2. Then after A 2 3, it will be negative of 1, minus 1, 3, minus 2, and the answers will be minus 2 plus 3 will be ultimately minus 1. After this, let us come to the third part. I mean A 3 1, that is equal to, positive sign convention will be used here. So minus 1 2, then 2, minus 3. The result will come as 3 minus 4. It is minus 1. then A32 will be negative of 1, 2, 0, minus 3, and I shall be getting 3. Then A33, for this the sign convention will of course be positive, so I get here 1, minus 1, 0, 2, and our answer is 2 here. So these are the results for all the cofactors of this given matrix. So I shall construct the adjoint now. Now adjoint of A is equal to this cofactor matrix. I have to write 2 minus 9, then after what do I get here? It is minus 6, it is minus 6, then after 0, minus 2, minus 1, then minus 1, 3, 2. Let us find out its transpose. Finding out its transpose, we get 2, 0, minus 1, minus 9, minus 2, 3, then after minus 6, minus 1, it is 2. So these are the results I got for adjoint of A. Next, there comes inverse of A, which we have to find out next. So after this, therefore A inverse is equal to 1 by determinant of A into adjoint of A, that is equal to 1 by negative of 1. Actually the determinant value already we derived as minus 1, so I can put it like this: 2, 0, minus 1, minus 9, minus 2, 3, then minus 6, minus 1, it is 2 here. So this can be the answer. This minus notation actually we can put inside the matrix so that the signs get reversed here. 0, 1, then all the negative terms will turn positive. 2, then minus 3, then after 6 here 1, minus 2. So this is our ultimate answer for this matrix. Next, let us come to question number 11. In question number 11, let the given matrix be considered as capital A. This matrix involves some trigonometric terms: 1, 0, 0, then after 0, cos alpha, then after sin alpha, then there comes 0, sin alpha, then minus cos alpha. So here in this case, first of all let us find out what is the determinant value. So expanding along the first row, I get here determinant of A 1 into cos alpha, means these two terms we are getting multiplied. So minus cos square alpha I get here, followed by minus sin square alpha. So let us take common minus here, and we can put here cos square alpha plus sin square alpha. The result comes as minus 1, which is not equal to 0. Therefore A inverse exists. Now let us come to the part of adjoint. The cofactors we have to find out. So the cofactors of the given matrix, capital A is equal to 1, 0, 0, then 0, cos alpha, sin alpha, then 0, sin alpha here, minus cos alpha r. So we can write here A11, it will be with positive sign convention, and the elements will be cos alpha, sin alpha, then sin alpha minus cos alpha. Actually it should be in determinant form. So this is equal to ultimately minus cos square alpha minus sin square alpha. So result comes as -1. Similarly, A12 will become negative of, these we have to consider 0 sin alpha, 0 minus cos alpha. Result will come as 0. Then A13 will become 0 cos alpha, then 0 sin alpha. The results will be 0 ultimately. Then after, let us come to A21. A21 is with negative sign convention, so the elements will be 0 0 then sin alpha minus cos alpha. The result will be 0. Then after, A22 will be with positive sign convention, then 1 0, then after 0 minus cos alpha, and our answer is minus cos alpha. Then after, A23 will be with negative sign convention, and the elements will be 1 0 0 sin alpha, and the terms we shall get as minus sin alpha. And after that, let us come to A13, the third A31. These will become with positive, actually this will come with positive sign convention, and the elements I should get here as, let us check once, the elements should be like 0 0 cos alpha sin alpha, 0 0 cos alpha sin alpha, answer is 0. Then A32 will be with negative sign convention, A32 with elements 1 0 1 0 then 0 minus cos alpha, 0 sin alpha. That is equal to minus sin alpha. Then after this we get A33 is equal to, the elements will be 1 0 0 cos alpha, 1 0 0 cos alpha, and our result will become only cos alpha. Now let us place these elements in the cofactor matrix. Therefore, adjoint of A is equal to, these can be written as, let us first consider the first row elements. This should be -1 0 0. So let us write -1 0 0. Along the second row, the elements will be 0 minus cos alpha sin alpha, 0 minus cos alpha sin alpha. Then after, along the third row, 0 minus sin alpha, then after we get cos alpha. So these are the elements we got here. This should be actually minus sin alpha. So after this we have to find out its transpose, and then we get minus 1, 0, 0, then after 0 minus cos alpha, then minus sin alpha, then after 0 minus sin alpha, then after cos alpha. So this is the result for adjoint of A. After this, therefore A inverse is equal to 1 by determinant of A into adjoint of A. So the determinant value, as we have calculated already, is minus 1. So we can put it like this. So minus 1, 0, 0, 0, minus cos alpha, minus sin alpha, 0, minus sin alpha, then after cos alpha. After this we shall be getting 1, 0, 0, then 0 cos alpha, sin alpha, then 0 sin alpha, then minus cos alpha. So these are the elements of this matrix, I mean inverse of this matrix. Thank you.